been living in Shenzhen for about 2 years now. I'm going to be talking about my new product that I'm crowdfunding named Pocket Popcorn Computer, or Pocket PC for short.
Feel free to hold. You can actually rest the microphone on your chin. Okay, so I'm not very sorry.
So I'll just give a little agenda of what I'll be talking about today. The history of Popcorn Computer would originally started as a Kickstarter campaign for a $9 computer, and Pocket Chip, which was the keyboard, display, and battery for the $9 computer. The new next-gen version of the chip, which was the Popcorn Computer and Kettle Pop. I'll be talking about Pocket PC, the early stages of development. Pocket PC also has a long-range radio functionality. I'll be also talking about alternative crowdfunding options. So if you're thinking about crowdfunding something, you don't have to only use Kickstarter or Indiegogo. There's a third option. I'll get into that a little bit about the infrastructure and technologies used to make your own crowdfunding platform, and some things to be aware of in doing that. So my company name is Source Parts. We source, design, assemble, and test products. And to kind of test that kind of system, I created a brand of computers named Popcorn Computer. Because I had previously been working for a company that did a Kickstarter campaign that raised $2 million. And so we raised $2 million, and we had about 40,000 backers. And half of those backers weren't for the $9 computer, but actually for the Pocket Chip, which I have here. And we sold that for $49. So about $1 million is just for this device here. And if you search Google for portable Linux terminal or hacker terminal, you would find this device. And unfortunately, this company went out of business because the $9 computer cost $16 to make, and the cost couldn't get down. And due to some other reasons, that company is no longer in business. This is Pocket Chip. So if you can't see it here, you have a closer view. The main design was based around the PCB itself, and it has some GPIO connectors, so you can experiment, kind of like an Arduino. The chip, which is the $9 computer, would plug into the back like a Game Boy. This was heavily inspired by the Game Boy. The keyboard used the snap tones, which were originally intended to be used with the silicone overlay, but a lot of community members 3D printed their own keyboard overlay for this, and it was much easier to use. The display was very low resolution, so the original goal of this device was to teach kids how to program, or teach kids how to code. And it shipped with Pico 8, which was a virtual game console. And you can program it in Lua, which is a programming language. One of the other features that you can see here is that we actually built a hole for a pencil, so that you can use the pencil as a stand to kind of hold it up. Some other, there's a very big community. Since we had almost 40,000 backers, we eventually sold about 100,000 units. So there was a very strong community around these products, and this is called the hacker chip or the hack chip, and they use this for penetration testing, for different kind of Bluetooth scanning and Wi-Fi scanning, to connect different USB devices. This is the back of the device, where after adding all these things on top, it was kind of hard to charge it, so he actually built in a wireless charger into the device. And this was all injection molded, so it was very easy to drill through. This was a kind of an April Fool's joke that we did, and this is a VR console, a kind of VR headset that we used. And it was based on the Google Cardboard. So you could 3D print this headset with actually use elastic band and the same magnifying lens from the Google Cardboard, and you could use it just like a VR headset. Of course, it was, I didn't have a picture of it actually wearing it, but it was a very big thing on your face to hold, so it was just an April Fool's joke. So after the company went out of business, I moved here to Shenzhen. I was the lead electrical engineer on it, and I wanted to make the next gen kind of version of this $9 computer, but improve a lot of the usability issues that people experienced when using it. One of those, for example, was that we use a micro B USB connector, and that caused a number of issues with people using power-only cables and having difficulty in communicating with the computer to program it. Other problems was that micro B has various chargers that were given to people with when they bought a cell phone, for example, and they all have different ratings. So this device was pretty power hungry, and it would black out or brown out when people try to do something serious with it, or even just plug in a keyboard or mouse, the computer would brown out. So I wanted to solve those issues by using USB-C, which has power negotiation, and the USB-C chargers can communicate with the device, and the device can tell exactly how much power it needs. So that way it can eliminate that problem altogether. Another problem that we had with the $9 computer was to cost down the device. We used a certain type of storage technology called NAND. And NAND is managed by the CPU, which is over there. And also, so when it's managed by the CPU, a lot of the CPU power, and this was a $9 computer, it was a 1 gigahertz processor, so it wasn't very powerful in terms of speed. So most of that speed was being used to manage the memory. When you're dealing with that as well, since we had these power issues, when the device browned out, the storage would be unreliable. So people would lose files, they would corrupt their device, and it would never boot again. So they would have to reflash the device. So I solved that by using a different type of storage named eMMC. And this is basically an SD card on a chip. And the management is done inside this chip. This chip is actually 2 silicon die. It's the NAND flash and the controller that manages that flash. So that once I added this new type of storage technology, the CPU was free to do other things, and it ran much faster. You also might notice this was the first revision. This is Rev 1 that I made after after chip. So you may notice there's a lot of components missing. Here, for example, also there's a lot of components there. There's a big chip over here missing. And this is the USB-C controller. So the power negotiation was managed by this chip. But when I originally designed this PCB, I selected a chip that was very popular in terms of its availability in the market. And that can be a mistake if you're just going by how many components are available on the market, because it may be that component is available on the market because no one wants to use it. So I later found out, after getting the PCBs manufactured, that there's no software support by Cypress for this chip, because this was the first version of that chip that they made for USB-C. And this was actually one of their microcontrollers that was specially programmed with software to work with USB-C. So it wasn't even a special USB-C chip. So if they had given me the software to develop for USB-C, they would be giving away their secret sauce. So when I was looking for the software, I visited the company and I said, I need the software for this chip because my PCBs are currently being manufactured. And they said, we can't give it to you. I said, well, what do you want me to do? My PCBs are currently in the factory being made. And they said, well, you need to stop making them. So this caused me to lose a lot of money and time using a chip that was not supported by the factory because I sourced a component that was available in the market. So my recommendation is not to use Cypress or ON Semiconductor for a whole other reason. And that is ON Semiconductor is not really available in China because they only care about Tier 1 customers. And Tier 1 customers are like Huawei or any cell phone manufacturers. And that's something that's actually told to me by an ON Semiconductor employee. So what did I do? I needed to find a USB-C component for my board. So I went to the SEG marketplace and I started finding USB-C adapters and cracking them open and seeing what chip they use for USB-C. And I found this LDR chip. So I did some research online and I found out this is called Legendary. And Legendary is in Longhua. So I took the Line 4 train and visited the factory of the company. And I said, do you have someone who speaks English? So they said, yes, we do. Come on over. And I was speaking to the person there, and I later found out that he was the CEO. And he's a very nice guy, and runs, his ICs are being used in almost all the adapters available on the market, the inexpensive adapters, and they're actually great chips. So if you're looking for a particular component that's easy and available to source, then one of the things you can do is find out what's available on the market and crack it open. So this is the new version of the popcorn computer, and we used the new Legendary chip. One of the things I forgot to point out on the other slide was that there was another component that was hard to source, and that were these resistor networks. And these resistor networks are only available from a distributor in Beijing, and they cost about 30 cents a piece. So this was originally on the $9 computer. So this is one of the reasons why the $9 computer costs $16, because there's a number of these resistor networks used for the signals between the memory and the CPU. And I remember during manufacturing that because we could not source this component, which was only made by Panasonic, this delayed manufacturing for a couple of weeks until we can get it imported into China. So this is a very expensive component. What do I do? Well, I chose, it's a very small component as well. It's 0201 times 4, so it's 4 resistors in a single package. So we chose, so I said, let's use the bigger size package. The bigger size package is 4 cents each. So you go from 30 cents to 4 cents a component, and we had to just do a redesign, which wasn't simple, but that redesign saved us a few dollars on the BOM. So if you just go with a bigger package sometimes, and you have the space, then you can save a lot of money. So this is a system on module. This is the same thing as the chip and the $9 computer, just in a smaller SMT-ready device. And you can see over there it uses 2 of those small resistor networks that were hard to source and they're expensive. So using just a bigger package, we're able to reduce lead times and cost at the same time.
What's the module that was on that? Yeah.
So this is the same thing as the $9 computer or chip. This is the GR8, which was a system and package that we made. So this is actually 2 silicon die in 1 chip, and that's the CPU and the memory. So by creating a system and package, we eliminated those 30-cent resistor networks because they're now built into this device. So if you're making a lot of something and you're using a CPU and memory, and I'm talking about millions of units, then it may make sense to make your own IC where you can combine the major portions of your circuit into that chip to save time and cost. This also, since you're combining the memory and the CPU into 1 chip, you can also simplify the board design and the time it takes to make the board. So this is a Wi-Fi module, Wi-Fi Bluetooth. This is the CPU memory. That's the power module, and that's the storage over there, using the new storage that has the controller built in to manage the memory. So since I had a big part in making the pocket chip, and that was about a year of the design effort to get that out the door, there was a big community of people who had this device and wanted to use it, continue using it. So the popcorn computer, which is pin-to-pin compatible, they can just plug into the back and have an upgrade that's much faster because that's a different type of storage technology. So I did a Kickstarter for those 2 boards that I had just showed you, the popcorn computer and kettle pop, and the Kickstarter only raised about $5,000. Our goal was $250,000, but since the goal was realistic in terms of the amount of components that we needed, that gave us positive marketing in terms of this next product that we're making. So people said, if you made a new version of Pocket Chip, then I'll back you. So we got a lot of feedback from that Kickstarter, even though it failed, that people wanted to see a new version of this portable Linux device. So I did research, and this is a form factor that is desired by a lot of people because they're taking Raspberry Pis and displays and keyboards and making their own devices because this is something that doesn't exist in the market currently. So this is one such example called the Zero Terminal. It has a Bluetooth keyboard, a Raspberry Pi display, and a battery. This is another device that someone made called the Pocket Pi. This is again a Raspberry Pi display, battery, and keyboard. And I rather like this device because of the keyboard. And this design is completely open source, and the keyboard that he used, which is called the Q9, available on Taobao for about 49 RMB, was really easy to use, and it was much easier to use than the Pocket Chip because it had the silicon overlay. So this is the keyboard that I decided to base Pocket PC around. So we made some sketches based on how it would look. I went to the cell phone markets in Washanbei to source a display, and I actually went to Wikipedia and searched 1080p cell phone displays and had a whole list and found out what was easy to source in the markets. And I landed upon a Nexus 5 display, which was 1080p. It was about 65 RMB. This sketch was actually done by someone on Fiverr. So if you ever need some kind of sketch or 3D renderings, I highly recommend Fiverr, which is, they have high quality designers there that'll do quick turnaround on your design for not too much money. This is a render of Pocket PC. So I had given the designer a picture of the keyboard, and they were able to take that picture and create this render just from the picture. We decided to add USB-C for the ease of charging. So there's 4 USB-C ports, 2 on this side and 2 on the other side. And the battery was also another part that I found in the cell phone markets, which was an LG battery that was easy to source. This is a lifestyle render to gain kind of a sense of scale. So from this render that we got, we did a 3D print to do a form factor, looks like prototype, to kind of get a feel of where we right in terms of the sizing, in terms of this product. Another feature that we wanted to add was long-range radio, and that's LoRa. There's now a network called the Things Network that's being built out by people in their own homes, and there's over 10,000 gateways now. So the gateways, which I'll show on here, are all around the world, and long-range radio is very low power and long range, of course. So as you can see, Europe here has about 5,000 gateways compared to the United States. So Europe is the leader in this kind of technology. And the gateways cost about $80 US, and they're free to add to the network. So what you use this technology for is for IoT applications that are low power, like a smoke alarm, that would communicate with gateways that you have in your home, communicate with the network server, and you can view it on your application server, which would be your either on your phone or on a web dashboard. I also wanted to discuss what kind of alternate crowdfunding options there are. There's a company called Celery, and they charge a flat rate of 2% fee per transaction in addition to Stripe fees. And this is something I'm going to come back to later on in terms of Stripe for pre-orders. I didn't end up using Celery. I ended up building my own crowdfunding website, and this took about 2 months to build. And interesting part of this is that the template costs $19. So with $19 and about $2,000 in web development, we were able to get a full crowdfunding platform on our own website. This week we raised about $12,000 in 2 days. We're almost at our halfway point of $50,000. So this is the first part of the site. We added normal crowdfunding information, just about the technologies, about the Pocket PC, and including the sketch, the renders, and just used the kettle pop, which was the system on module, for the initial prototypes, which we'll be making in the factory next week. So people would pre-order 2 options. We have the regular Pocket PC and the Pocket PC with LoRa. And then we had to build a kind of user flow for people to place the order. This is called a modal. So a modal will pop up, and then you can select through and select your quantity.
Explain LoRa. Explain the LoRa.
Okay. LoRa's long-range radio.
Excuse me, how long? What's the distance typically?
Depending on whether you have line of sight, you can have up to 10 kilometers. Normally it could be 1 to 2 kilometers. It also depends on what kind of antenna you have. So if you have a chip antenna, it's shorter range. If you have a normal whip antenna, you can get much higher range. And it's very low power. So
Is it legal in China?
there is a band that is legal in China, and Tencent is building out the network infrastructure for that. So there's different bands in each country. There's US and European, Korean, and Australian bands.
So does your device connect to any of those?
Yeah. So we provide an option. So a user selects the Pocket PC with LoRa. They're taken to a screen where they can select which band they want to have their LoRa radio communicate
Is
on.
that hardware so that like it's hardware connected to that band?
So there's a few bands that share the same module. So the US and Europe share the same, almost the same band, but they share the same chip, the same module. China uses a fourth, which would be 800 to 900 megahertz. And China uses 433 megahertz, which would have to use a different chip. So it's actually the American and European bands are software selectable on the chip, so you can use the same hardware. So we designed a user flow and a UX flow for ordering. This is the flow that we used here. They would have to select a quantity. They would have to log in to our authentication system. As soon as they logged in, they're redirected back, and they would enter their contact and shipping information, their billing information. They would review and then pay. And they would pay through Stripe, which I'll explain here. On the front end, we use a technology named React. And on the back end, we use Amazon Web Services. And our payment processor is Stripe. So we don't handle any of the credit card information. That's directly sent to Stripe direct. So this is called serverless, because we don't have to host any servers of our own or set up any servers. We just use Amazon's Lambda functions. And we also use Amazon's CloudFront for basically having the fastest load times, because they have 18 edge locations, so 18 places around the world where they have servers. So when you connect, you're connected to one of the closest servers to you. So this helped when we got on the front page of Hacker News, and we got 16,000 views in one day. So we had no server downtime because we used the CloudFront. Which there's also Cloudflare, which is another type of cloud service like that. So beware, if you're going to use Stripe and build your own crowdfunding options like I did, I do not recommend Stripe, because this is the email that they sent to us. So this is not explained on their policy page. So first, they hold 100% of the funds that you receive until you have manufacturing contracts, which they'll release 20%. Then they'll continue holding 80% until you begin manufacturing. And then 30 days after your goods are shipped, as verified by tracking labels, they will release the remaining funds. So if you crowdfund on your own platform, then you will need to have alternative funding beforehand. Otherwise, you may get into this issue. Also, we use MailChimp, which is now blocked by Firefox. So you will have users unable to sign up to your newsletter.
Internationally blocked by Firefox?
Yeah, if you have Firefox with tracking protection enabled, all MailChimp is blocked. So yeah, they're one of the major newsletter or mailing list providers, so I highly do not recommend them for using it as your newsletter provider. They're also very expensive. So yeah, that's my presentation. If anyone has any questions on Laura or in terms of development, let me know.